Part C, right triangle trig. You learned back in geometry about the 6 trig functions, all defined in terms of a particular angle. In a right triangle, we have the side opposite that angle, the side adjacent to that angle, and then the hypotenuse, the side across from the right angle. The sine of our angle is the ratio of the opposite over the hypotenuse. Its related function is the cosecant of theta, which is the hypotenuse over the opposite, just the reciprocal. The cosine of an angle is the adjacent over the hypotenuse, and its related reciprocal function is the secant of theta, the hypotenuse over the adjacent. The tangent of theta is the opposite over the adjacent, and the cotangent of theta is the adjacent over the opposite. With this in mind, if we're told that the sine of theta equals 3/11ths, and that theta is some acute angle, we are asked to find the cosine of theta and the tangent of theta. Well, I think the first thing I should do is draw out a triangle for this situation. I have my angle theta, and if my sine is 3/11, that means my opposite is 3 and my hypotenuse is 11. I'm going to fill those values in, and now I can just use the Pythagorean theorem to find the missing side. Well, 11 squared minus 3 squared gives me 121 minus 9, so that gives me 112. My other side is the square root of 112, but you can simplify that. You can divide by 4, and I can say 2 root 28. I can simplify 28 down to 4 times 7, so I should end with 4 root 7 on that side. Now that I have a filled-in triangle, the cosine of theta is just the adjacent over the hypotenuse, so 4 root 7 over 11. And the tangent of theta is the opposite over the adjacent, so 3 over 4 root 7. However, I don't really want to leave a root in the denominator, so I will go and rationalize my denominator, multiplying the top and bottom by the square root of 7. This gives me 3 root 7 over 28 for the tangent of my angle theta.